We here we go. Awesome.
Yeah.
Awesome. Great. Well, again, thanks everyone for having me on. My name is Jose. I'm the founder, managing director at Integrated Projects. I'm an architect by trade, also interested in construction and design technology. And I'm really excited to share with you guys a new product that we launched quite literally as of Monday. I'm losing track of the days, but okay, Wednesday. So just 2 days ago. But with that, for the past 4 years, we've been focused on integrating and answering some really fundamental questions about buildings. And in the context of the metaverse, what we're excited about is now we do see a very clear bridge from what we do, producing 3D models of, in real life assets, and then putting those on the metaverse in an accurate way. So with that, some of my team members are on the call, so I appreciate that. And Suli, I believe, is on the call, Alvaro, Pat, and potentially a few others. But what we're working on is combining 3D scanning technology with 3D modeling technology. And our original purpose was to start and help architects and engineers create accurate background models for the purposes of construction. What we realized, though, in that process is that because these files are, in fact, not just accurate, but compatible with metaverse platforms, what we're finding is a really interesting breakthrough moment. So let me see if I can pull up a few examples, and I'll kind of walk you guys through a quick presentation. Let's see here. So I'm going to quickly run through kind of the product and how anyone effectively now can 3D scan their own space, even using their phone, convert that into an accurate 3D model, get that effectively as a GLTF file, and then import that within their preferred metaverse platform. And our hope actually is we're looking for folks to collaborate with. We're experimenting what the right platform is for us and somehow integrate seamlessly so that effectively from a phone all the way to with just a few clicks of a button, we could onboard any in real life building to a metaverse to a construction grade level of accuracy. I'll quickly run through the problems. The reason we started doing this is because of bad building information. So for the past 4 years, we've sat down with architects, engineers, builders, real estate developers, and the common theme has been inaccurate, incomplete, or just non-existent information. And by bad, we mean, inaccurate and incomplete, but information, we mean the 3D and 2D files, as well as the ones and zeros that come from a building information model. Ones and zeros being things like square footage or quantities of equipment or material. So what we're looking to do is bring good information and focus on capturing good information, right? We believe that by doing that, we can begin solving a lot of the pain points and challenges that happen when people are designing, building, and operating spaces. So the goal is we're trying to figure out a way to produce accurate, comprehensive, and accessible 3D models, not just for the kind of fancy clients that can afford it, which, frankly, we've had opportunities to work with some really amazing companies and organizations. But what we realize as well is that there are more buildings in the world than there are websites. And so with that, we feel that the problem is so large and so big that we're going to be working on this for a very long time. Whether it's homes or offices, hospitals or hotels, data centers or warehouses, while all of these spaces might be different in their use, they're very similar in the characteristics of or requirements of needing to capture physical information and translating that into digital information. And for the past few decades, two different but complementary technologies have evolved to allow for this kind of one-to-one creation of the digital asset matching the physical asset. The first technology is reality capture, or you've heard of 3D scanning. This technology is relatively expensive, right? And so in the last 10, 20 years, these cameras have been very specialized, and the people who could afford them are very few. Often these cameras costing 200,000 US dollars, 100,000, 70,000, 50,000. As technology has evolved, this technology has also become more affordable, right? And for example, the next iPhone 13 that's supposed to come out in October now is being equipped with Generation 2 LiDAR. And the reason this matters is that now what used to take several hundreds of thousands of dollars and very specialized equipment, now anyone with an iPhone 13 or an equivalent kind of Samsung can take out their phone and capture space relatively accurate, right? And we think that this is a big deal, but only the first part in a kind of a two-part effort. The second part is the evolution of building information modeling. And we've come a long way, right? From stone-based carvings to paper-based carvings, paper-based drawings to CAD, right, in the 80s. And then in the late 80s, 90s, the first introduction of 3D CAD, right? What these two technologies have allowed us to do is to begin addressing not just how we design buildings, but also how we capture and document the existing conditions. So if design represents the question of what should be, we're trying to figure out what is. And we believe that by answering what is, we have the opportunity to develop better buildings and design better buildings. But we do believe that answering this kind of layer one challenge is what sets us up to then move on to and empower architects and engineers to focus on layer two solutions. So BIMIT is trying to do exactly that, right? So now anyone, whether an architect, engineer, they're 3D scanning spaces either with some folks with their phones, other phones with LiDAR-based equipment like Pharaohs or Leicas or Navises, or even more affordable options like Matterport. Now anyone can walk into their space, 3D scan it, and then effectively use us to then be able to create accurate architecture, mechanical, electrical, plumbing, and furniture and equipment. And it's what we do with this model afterwards that is really the turning point, particularly in the gateway to the metaverse. So a quick kind of rundown as to what BIMIT is and how to use it. So the site is actually live. Anyone on the call right now can go to the website. It's just www.integrated-projects.com. And I'll, of course, link to it at the end. But now we try to make it so that with just a simple few clicks, you can convert your 3D scan into a model. And that model is going to come with files compatible to uploading to the metaverse. So what we're trying to accomplish with this particular product is we want to be able to deliver BIM, meaning building information models, in hours, not weeks or months, which is typical to the current kind of architect and surveyor and engineering workflow. We want to be able to deliver BIM at fixed low rates. So as opposed to having to submit an estimate for every single order, we want to deliver BIM in a single file that includes architecture, furniture, and MEP. We want to include BIM as a source so that you can quantify what you have, meaning you can count your spaces, your equipment, your materials. And we want to deliver that in a standardized level of detail 200. So we're paying close attention to the accuracy of location, orientation, geometry, and sizing. So this is just a quick still, as well as a description as to what exactly is included within each of the three scopes. Architecture, of course, including walls, floors, doors, windows, columns, etc. And all the way up to MEP, including pipes, conduit, ducts, power, and data outlets. At scale, the reason this matters for a variety of people is that now, for the first time, we're able to look at spaces and compare apples to apples to apples in a clean database where we're now able to understand square footages, quantities of equipment, material. For real estate owners that own, say, 1 or 10 or 20 or 100 locations, the ability to quantify, not just across one location, but several, or your entire real estate portfolio, now is possible, right? Before, because so many different consultants, architects, engineers had their kind of hands within the existing conditions model, it was very difficult to standardize what that file was, what output was out there. So what we're trying to do is create kind of a verified database where anyone essentially that digitizes their space with BIMIT can trust that at least it was captured accurately. And so this is kind of the simple step-by-step. If you're on the website today, you can simply drag and drop your point cloud into the website. There's a current file size limit of 5 gigabytes, but of course, if your point cloud is larger, we've had as large as 100 gigabytes. You can simply just add your Dropbox or whatever kind of storage system you're using here to send over your point cloud. Of course, if you're located in North America, you're probably wanting your project in Imperial. Everywhere else in the world, you can just simply select your preferred unit of measurement. We've categorized the size of each project into 7 tiers, with the first tier representing the smallest, the 7th tier representing the largest. Tier 1 represents your average, say, apartment, whereas tier 7 represents as large as a large warehouse, right? And so you can imagine these projects kind of have varying degrees of complexity and scale and size, but ultimately, kind of our process is being able to handle everything. Of course, you're able to choose whether you are looking for a model that includes the architecture, the furniture, and the mechanical, electrical, and plumbing. A good rule of thumb is that your point cloud has to visibly show these scopes. So in other words, if you 3D scan a space and your mechanical system is hiding behind a wall or a ceiling, if you cannot see it in your point cloud, we will not be able to model it or process it. So keep in mind that we will essentially be able to model exactly what's being shown in the point cloud. So if there's a missing room, we're not going to be able to make assumptions on that. So the kind of scanning best practices require us to, and kind of collaboration, right, between the 3D scanner and our team. We make it really simple, right, to pay. So essentially it's kind of a few clicks and you're ready to check out. 50% of the funds go to upfront, and then 50% of the funds go upon checkout of the order. Now, of course, we're exploring ways to connect the crypto wallets. We have a little bit more work to do. And so if there's anyone on this call that has a lot more experience with this, please do reach out to our team. If Austin is here on the call, he's leading up all engineering, and definitely we need some help. We're a relatively small team, but doing some great work here. Once you've placed the order, depending on the size, we'll email you when the order is ready. So you'll be able to download your RVT, your DWG, and your GLTF files all in that folder, as well as the opportunity to share that 3D model with the world in Twitter or whatever platforms you're looking to use. This is just a quick summary of the file formats that we deliver for every single project. One Revit file. The CAD files will deliver one floor plan per floor for your order. If you request MEP, we will also include the reflected ceiling plans, and again, one per floor. We're exporting now the GLTFs, as well as we're just kind of submitting the point cloud file as a converted RCS file back to you. This is just one screenshot of the many models we've done. Again, you can imagine for the architects here on the call, what can be done with these existing conditions models. Everything from actual construction to renders, visualizations to animations, etc. And so I guess with that, I will stop kind of the show and tell, and curious to hear if there's any questions, any ideas. We definitely need a lot of help. We're very much, at least when it comes to integrating with the metaverse, we're definitely looking for collaborators to do some interesting work together.
Wow, thank you very much for great presentation. I'm very excited of what you have shown us. It's amazing, and congratulations for such a great project you did, or great work. That's amazing. I think as an ArchiDAO, we would really like to work together and help you with this project, right, Mayur and Taricha? What do you think?
Yeah, definitely. I think we are in the space of accessible and metaverse creator economy for architects, and this workflow really help for more people to even share their current experiences and host events, because maybe not everyone is well equipped for that asset creation, but this type of things enables even their room or bedroom to host an event with their friends in metaverse. So there are things which this workflow enables, which makes it more accessible.
Yeah, as you said that you are looking for some folks to collaborate. I attended some other ArchiDAO's meetings, and I've met quite interesting guy. I don't remember the name anymore, unfortunately, but I will look it up. And he also focuses on BIM models and creating like a super detailed models with every screw and every single nanoparticle of the building. So it might be interesting maybe for you or also for him to connect. Then our also great member Theo is a Solidity developer or a blockchain developer and architect who also focuses on 3D scanning or knows a lot about like the point clouds and stuff like that. So it would really interest him, I think. And we have a parcel in Decentraland. So if we connect somewhere on a signal or on some safe place, I can share a wallet that has like moderator rules for this parcel, and you can experiment with implementing models in there and see how it works. Because every metaverse has its own limitations. For example, in Decentraland, for one parcel, you can't upload more than a specific number of triangles, which is, I think, 10,000. And also there can be only 2 textures, which is really limiting. These textures are only 512 by 512 size. We can discuss it later about some these technical details. You can, in Decentraland, for example, use URL an images with URL address. So there is like, it's not a texture in the parcel, it points somewhere to the internet. And in this way, you can have like a bazillion of pictures in one parcel. So there are like workarounds which we can think about. And maybe it might be interesting also to, if you have a website with like these textures and these parts, the Decentraland may even, the parcel may point to your server with all these things.
Yeah, absolutely. Absolutely. And that's actually that level of detail is actually what we're looking to experiment with, and to determine what are some of those limitations currently. For example, to use your Decentraland example, um, and Meyer, for example, your video comparing the different platforms was incredible, right? And it actually started some conversations um, internally with the team about what are like you said, the pros and the cons, some of the limitations. I think that I guess so. Question for you, Myers, like what of all of the different platforms, um, which exist currently that would lend themselves to being kind of an accurate depiction of the real world? So in other words, if we had the ability to 3D scan a home, right, or office or an apartment, and we all were able to kind of get accurate um, architecture and engineering, and begin creating an accurate depiction, what platforms are currently the best suited for that, if any?
Yeah, I think like the one of the leverage you guys have is like getting the texture and in a photorealistic manner. So I think metaverse is like somnium space would give like a justice to all the detail like model you have, because we definitely don't want to compromise it and compress or retexturize it for voxel base. Why don't we leverage what we have from your detailed model and showcase in the metaverses which support that kind of high fidelity?
I'm curious, what are some of the more interesting use cases? Like, I'm trying to imagine, or maybe have the foresight, if within the platform that you mentioned, is if we were all able to accurately digitize our own homes or our own offices, uh, what are some more meaningful use cases that, whether they have to do with visualization or design or hosting virtual events? Or I'm curious, what you've seen.
Yeah, I think like, so one thing which becomes very interesting when, which is one of the experiment I'm doing, is like bridging digital physical with IoT and like projection mapping techniques. Since you guys have a very good accurate of the whole physical space, you could literally do like connect with like a GPS sensor or even like accelerator meter, where I can have like a projection on my, let's say, my ceiling. And if people are in the same space in my metaverse, I have like some replica or some indication that these are the 4 people on my floor space standing in metaverse. So in physical space, I could correlate with them, and also same replica in the metaverse. And things become very interesting, where once if I can talk in physical space with people in avatars in physical space, I can have more collaborative environment, which becomes very interesting. And those people can operate lights. Let's say in my physical space, I can turn off the light and it changes lights in metaverse space. But it
Yeah.
requires like a bit of a bi-directional communication, which could become very interesting experiences.
Yeah, exactly. In other words, if I understand correctly, you're suggesting, like, if the kind of the layer one information has been verified and accurate as a background, the added layer of maybe IoT or the Internet of Things that have sensors embedded into those that send then information back and forth, we can
Mhm.
essentially see a digital version, your building, for example, sending back data as to how your systems are working, how many people are in there, heating or cooling or electricity. I think this is kind of the idea of the digital twin. But what's most exciting about a true metaverse platform is that it doesn't really exist within kind of a private server, but rather, anyone essentially can now begin digitizing their own spaces. Um, from a technical level, this is it's not lost on us how many layers and factors need to be in place to make this happen. We're really good at creating that kind of layer one, just creating and producing the asset. those integrations with layer 2, like just, you know, the Internet of Things, sensors of certain things, those are the conversations that we definitely need to have, and we're certainly open to discussing with your team, as well as like, we have the models, but like, now what's the proper platform to even build on, right? Like Jerry was saying before, Decentraland just has some clear limitations that may or may not mean, you know, it would actually compress the amount of information we have, which may be limiting, right?
Yeah, and one more use case is also, I was playing with like a platform called Immersal, and they have a SDK where they do like geographical mapping. So if you have, let's say, AR experiences which you want to augment in IRL spaces, like literally you could have like portraits which has some marker, and which if you are able to track in your 3D model, then you can import in like various platforms and create like a augmented reality experiences based on those markers.
Mm-hmm. Absolutely, and those are the kind of I guess experiences we definitely want to to explore. I mean, the infrastructure, right, to kind of build these assets that are there. It's just now connecting them with these different use cases. Guys, in the interest of time, I want to be mindful. I know we had from 2 to 2:30. Alvaro, who's here on the call, he's actually leading a lot of our visualization and graphics efforts. I would love to connect some of our team members, and now we're part of the ArchiDAO community as well. But if we can continue this conversation on Discord, I think there's plenty to figure out. And even this conversation now has been certainly helpful, just to see how we can build. Meyer, for example, I saw your comment about you've already built in crypto wallet integrations, right? These are little things like this, I think, are going to go a meaningful way in making this even more accessible, right, to folks. And everyone, I guess, who's listening in the meantime, do please feel free to check out the website. I can also share it on the Discord. But yeah, technically, if you have a LiDAR-based camera or a phone, you can scan something now. Apps like Sitescape, Polycam, and others can help you create a free point cloud. You can just drag it and drop it into BIMIT, and create your construction or metaverse model.
Awesome. I'd also like to ask, like, from the community, if you have any questions you would like to cover.
We can also follow up on Discord if anyone comes up with any questions afterwards.
Perfect. Yeah, I love the whole platform and experience. Looking forward how we can collaborate and see how it can be developed. Yeah, lots of cool applications.
Yeah, absolutely, guys. And believe we're very much building this now. So every feedback we take into account. Just on Monday, we had kind of our launch event, and a user was like, "Hey, where can we find pricing?" Right, and that's a very important thing to have very clearly. So just today, we designed a kind of a quick price and timeline table right on the order page. So we're moving very quickly, and so any feedback or questions, please feel free to critique and criticize it. It can only help make the service better. So and thanks again, guys, for listening in. I know you guys are probably super busy, so thanks for your time.
Thanks, Jose. It was really nice to have you. Anybody has any question can drop in, maybe like in Discord. We can just continue this talk forward and innovate together.
Awesome. Thanks, everyone. Really a pleasure.
I see a couple of people tuning in from India. It must be pretty late. Thanks for joining.
Thanks so much.
Okay.
Thanks so much. Stay safe.